Good morning, children. Sairam. Children, today we are going to start new chapter, that is chapter number 3, understanding quadrilaterals. Okay, so let's understand what is quadrilateral actually. So any figure which has four sides, that particular figure is called quadrilaterals. So it can be square, it can be rectangle, it can be trapezium, it can be rhombus, anything. Okay. Okay, so now quadrilateral can be any figure which has four sides. So it can be square, it can be trapezium, it can be rhombus, it can be rectangle, anything, but it should be of four sides. Okay, children, but in this chapter we are not going to understand only about the quadrilaterals. We are going to understand about polygons as well as. Okay, so let's see what we are going to discuss today. We are going to discuss first of all introduction of the chapter, what is there in the chapter, a brief introduction about that, and today from the exercise 3.1 we are going to solve two questions also. Okay, children, in this chapter we are having four exercises. So today we will do only two questions from the exercise 3.1. But before that, we have to understand this chapter very carefully. Okay, see, now what is there in the introduction? First is polygon. Now what is polygon? A simple closed curve made up of only line segment is called polygon. So what statement is saying? A simple closed curve. Children, here you need to understand one thing. What is the meaning of curve? Curve means like you are drawing any line segment. Okay, at one go like this. If you are drawing, so this is a kind of curve. If you are drawing like this is a kind of curve. You are not stopping anywhere, so that is called simple curve. Okay, one more time, let's try. If I am making this line segment, so that is also a form of curve, children, because at one go I am making this line. Okay, children, so that is the meaning of curve. Now what is the meaning of simple closed curve? Simple closed curve means like if I am making like this kind of figure, so it is a kind of curve like this. It is a kind of curve, but it is closed also. From anywhere it is not opened, so that is called simple closed curve. Okay, two words I have introduced you. First is simple curve, second is simple closed curve. Simple closed curve means anything which is closed, which is not open. Okay, but it should be curved also. Okay, children, so I hope you are getting my point. What is the difference between simple curve and simple closed curve? Now come back to the polygon. Now what is polygon? A simple closed curve made up of only line segment. Now when we are talking about curve, so line segment like this, it is a kind of line segment. This is a simple closed curve and simple curve. Okay, but if I am drawing like this, so we can say that it is a simple curve and closed curve as well as, but it is a polygon. Why polygon? Because in this line segments are there. This diagram is made up of line segment. Above diagram is not a polygon because in that curves are there, not a line segment. That figure is not made up of line segment. So above figure is not a polygon. Above figure is not a polygon and below figure is a polygon, because in this we are using line segments. I hope you are getting my point. If you are not getting my point, children, the first exercise of this chapter is based on only these types of concepts only. There I will make you more clear about polygon, about simple curve, about simple closed curve. Many examples are there, we are going to discuss that also. So let's see what is there in the next slide. Now few pictures are there, curves that are polygon. So we are having two types of figures here. Curves that are polygons means those curve which we can say that it is a polygon also. Like see this picture, in this triangle is like this. Okay, it is a closed curve, we can say that it is a closed curve, but in this only line segments are participating. So that is why we can say that this particular curve behaves like polygon as well as. Now let's check this. In this also we can say that it is a kind of curve, but line segments are also there. So this simple closed curve is also a kind of polygon. Let's check out this diagram. This is also a polygon. Okay, now curves that are not polygons, let's check out that. See, this is closed curve. This is a closed curve? No, because these two line segments are out, they are not polygons. Curves are there because we are making such kind of curves, but it is not a closed curve, as well as we can't say polygon because in this zigzag lines are coming. Okay, in polygon zigzag should not be there, like this is also kind of polygon. Okay, now this second figure, this is also two diagrams are coming out in this. So it is a curve, it is not a polygon. Okay, now this is not this is not closed, this is open, so this is also not a polygon because it should be a simple closed curve. Okay, now let's see what is there in the next slide. Now number of sides and number of vertices are there, classification and simple figure. Okay, what you are having in this, you are having classification of polygons, different polygons. So in this triangle is a polygon, quadrilateral because four-sided figure is there. Pentagon means a kind of figure which is having 5 sides. Hexagon, kind of figure which is having 6 sides. Heptagon, 7 sides. Octagon, 8 sides. Nonagon, 9 sides. Decagon, 10 sides. A kind of figure which is having 10 sides. So it is having 10 side figure. So all are polygon. All are simple closed curve. All are closed curve. All are polygon. Okay. Now let's see what is the meaning of diagonals. Now diagonal is a line segment connecting two consecutive vertices. Now if we talk about this rectangle, this is a rectangle, and this side and this side and this side and this side are equal to each other. Now it is a kind of quadrilateral also, we can say that. So what is diagonal? Diagonal means, so this point are called vertices, and when we join these 2 points together, these are called edges. These are called edges, all of them. Okay, when 2 vertices join together are called edges. Now in this, what are diagonals? Diagonals are these two. Okay, these two are diagonals. Diagonals is a line segment connecting two non-consecutive vertices of polygon. So 1 2 3 4 5, 1 2 3 4 5. So pentagon is there, we need to find out diagonals. So in this way it is connecting, in this way it is connecting, in this way it is connecting. So all are the diagonals, lines which are connecting through vertices inside, through the interior part of that particular diagram is called diagonals. Okay, now let's see this triangle. So one external point is there like this, so these are the diagonals, all 3 lines are the diagonals. Okay, now let's move to the next slide. Next slide is types of polygons. Now polygons are 4 types. First is convex, concave, then regular, then irregular. Little differences are there, you have to understand that. Now convex polygons are those polygons which are having which are having angles less than 180, like square. So all angles are of 90 degrees, so it is a kind of polygon, but convex polygon, because all angles are less than 180. Okay, now in concave, one angle should be more than 180, like this. If we talk about this, so this angle is 180, more than 180. So this is a polygon we are using, we are making with the help of line segment. It is a closed curve, so it is a kind of polygon but concave, because in this one angle is more than 180. In regular polygon, all sides should be equal, all angles should be equal. Means this equilateral triangle, all angles are 60 degree, all sides are equal, so it is a regular polygon. In regular polygon, I am again repeating, all sides should be equal, all angles should be equal. In irregular polygon, in irregular polygon, children, all sides and all angles should not be equal. For example, trapezium, like this, all sides are not equal, because these two sides are also not equal, these two sides are not equal, so it is a trapezium, so this is a irregular polygon. So all the angles are also different in this, so this is a irregular polygon. Again I am repeating, a regular polygon is both angular and equilateral, means all sides should be equal, all angles should be equal. Okay, a square has sides of equal length and angle of equal measure, so it is a kind of regular polygon. Okay, so trapezium is example of irregular polygon, and square are the example of regular polygon. Now convex polygon are those in which all the angles are less than 180. Concave polygons are those in which only one angle should be more than 180. Okay, now the last concept in this chapter is angle sum property of quadrilateral. See children, we already know about the angle sum property of triangle. Means in that property, what we have learned that all the three angles of the triangle, when we add together, we will get 180. What is the angle sum property of triangle? Like if we are taking triangle, all the angles inside the triangle is equal to 180. This is the angle sum property of triangle. In the same manner, you are having angle sum property of quadrilateral as well. As again I am repeating, quadrilateral, any four-sided diagram is called quadrilateral. So in this proof is there, so let's see. So this is a kind of quadrilateral, so you are having 1 2 3 4 sides are there, so it is a kind of quadrilateral. So now we can prove that all the angles, see this angle, this angle, this angle, this angle, when combined together, it gives you 360. So you need to prove this. How? So what we have done, so I have drawn one diagonal here. Now this quadrilateral is divided into one triangle and second triangle. Now individually I will add this angle, this angle, this angle together in the triangle ADC, and when we talk about the below triangle, that is ABC, I will add this angle and this angle together, so that two equations form. After that, both equations add each other, then you will get and the sum of all the angles equal to 360. See how? See, now ABCD is a quadrilateral, join AC. So we have done that. A B C D is a quadrilateral, we have joined this AC. This we have done. Okay, now clearly angle 1 plus angle 2 gives you A. Angle 1 and angle 2, see angle 1 and angle 2 is representing A, and angle this 3 and angle 4 representing angle C. Okay, Now let's see when we talk about triangle ABC, so we are having 2, 4 and angle B together. Which triangle? Triangle ABC. So triangle ABC is this. So angle 2, angle 4 and angle B is representing triangle ABC. Okay, so when we are adding together, you are getting 180 angle sum property of triangle. So this is your equation 1. Now let's talk about triangle ACD. ACD, ACD. In this angle 1, angle 3, angle is there, combined together gives you 180 by angle sum property triangle. Okay, so this equation is written here, angle sum property of triangle. Now this is your equation 2 and this is equation 1. Now add both the equations. Adding the angles on either side we get, now this is your equation 1, this is your equation 2 and equal to 180 plus 180, so it will give you 360. Now in this starting I told you when angle 1 and angle 2 together it represent angle A, 3 and 4 represent angle angle C. So B and D is there, so hence sum of all the 4 angles of quadrilateral is 360. So with the angle sum property of quadrilateral is proved. Okay, now let's start with exercise 3.1. so this is very first question for exercise 3.1. now in this many figures there, 1 2 3 4 5 6 7 8 diagrams are there. Now you have to classify these diagrams according to these, like question is here, classify each of above figure on the basis of the following. So you are having option simple curve, simple closed curve, polygon, convex polygon, concave polygon. Okay, with the help of this, by using these options you have to represent these figures. Okay, so let's start with first we are having simple curve. Okay, so which are the simple curve? The first diagram is the first diagram is the simple curve. We can say that is a simple curve. S stand for simple, C stand for curve. Now second is also a simple curve. Third is not a simple curve because in this two diagrams are there and nothing is connected with each other. Okay, now let's talk about this third, this fourth. It is not a simple curve. Okay, now fifth is a simple curve, sixth is also a simple curve, seventh is also a simple curve, and eighth is not a simple curve. Okay, now let's talk about simple closed curve. Now simple closed, this figure is also a simple closed curve, this figure is simple closed curve. Now if we talk about this triangle, it is not a simple closed curve. This is also a simple closed curve, this diagram, and this diagram is also a closed curve. This is also a simple closed curve and this is not. Okay, now let's talk about polygon. Which diagrams are polygon? So first diagram is polygon. It is made up of line segment, so we can say that this particular curve can behave like a polygon. So this is also a polygon, so this is not in the category of polygon. Now this star is also a polygon because this is a closed curve. Okay, simple closed curve it was not, it is a curve kind of structure but made up of line segment, so we can say that it suitable for polygon. So this is a simple closed curve, simple curve, but it is not made up of line segment, so we can't take it as a polygon. Again, this is also not a polygon, this is also not a polygon because in this curve is there. Okay, this is also not a polygon. Now you are having three options in that: polygon, polygon, polygon. Now two options are there, one is convex and second is concave. Convex means angles should be lesser than 180. Concave means one angle should be more than 180. Okay, if you concentrate here, it forms angle more than 180, so it is a concave polygon. Concave polygon. This is a convex polygon. All angles are lesser than 180, and it is also a concave polygon. It is also a concave polygon. Okay, it is also a concave polygon because the this angles, inside angles, are also more than 180. Okay, so this is the solution in front of you. Simple curve is, these figures are simple curve, these diagrams are of simple closed curve. Polygons are 1 and 2. 1 and 2 are the polygon. Even fourth was also a polygon. Concave polygon was first, and 1 2 answers are missing. Okay, now let's talk about question number 2. Question number 2 is, how many diagonals does each of the following have? A convex, quadrilateral, regular, hexagon, and triangle. Now in this you have to you need to tell about the diagonals. Okay, so first you have to make the convex quadrilateral. After that you can make the diagonal. Second, you have to make a regular hexagon. Regular hexagon means all the sides should be equal, all the angles should be equal. Then you have to make a triangle. Okay, now this is your ABCD of convex quadrilateral. Means the angles are lesser than 180. So two diagonals are join this, so AC and BD will be your diagonals. Okay, now ABCDEF is a regular hexagon. 1 2 3 4 5 6 sides are there, so you can join all like this or like this. So these are your diagonals you can make. After that you will get 9 diagonals total. In that, names are AE, AD, AC, BF, BE, BD, CF, CE, DF. Okay, now third diagram is triangle. So here is your triangle ABC. No diagonals are there. Okay, in that, so we can say that in this no diagonal is there. So with this I am ending this video. In the next video we will move on with 3.1 exercise only. Take care of yourself and complete your work in your fair notebook.